In this video, we'll be tackling about Chapter 4, Boyle's Law. This is going to be the last video of our series involving the solving of word problems about the ideal gas law, combined gas law, Charles's law, and this time we'll be having Boyle's law. So, we know that we're trying to solve Boyle's law if our temperature has no data, or in other words, the temperature is constant. We don't know what the temperature is because it's not specified at the given word problem. So, with that said, let's start. Still, we have condition 1 and condition 2. The only um, the only thing that we don't have condition 1 and condition 2 is the ideal gas law, the one with the formula PV is equal to nRT. But apart from that, everything is condition 1 and condition 2. So, without further ado, let's start. Again, we have to enumerate PV and T, place sub-values to differentiate the pressure or volume or temperature over the other. So, 22.5 liters, that is our volume 1, of nitrogen at 748 mmHg, and then compressed to 725 mmHg. Right, that is P2. At constant temperature, constant temperature. Give me a few seconds to reconsider that part. Constant temperature. I suppose that there is nothing specified in regards to the temperature. Therefore, I think we have to acknowledge that there is no stated data. Both for T1 and T2. It's well said because Boyle's law, there is no temperature. Right, so we have to find a new volume, which is V2. But first, we have to convert the quantity of both pressures. We have to turn them into atmosphere. So, P sub 1, 748 mmHg to atmosphere. P sub 1 is equivalent to 748 mmHg times 1 over 760 mmHg. P sub 1, place that in the scientific calculator, and I'm so sorry, give me a few seconds to place the values in the calculator. Alright, we have 0.9842105263. P sub 1 is equivalent to 0.98421, rounded off to 5 significant units. And of course, place atmosphere. So yeah, that's the translated value of pressure 1. For pressure 2, it's equal to 725 mmHg turned into atmosphere. P2 is equivalent to 725 times 1 over 760. Oh, it's a bad handwriting. Let's fix that. Alright, place those values in the calculator and we'll get 0.9539473,684. In other words, round that off to 5 significant figures, 0.95395 atmosphere. Alright, we're done with the conversion. There's nothing else to convert. Let's go with the equation. As always, we have to base, with problems involving condition 1 and a condition 2, our equation will always be based upon the combined gas law formula, which is basically PV over T is equal to P2V2 over T2. So, apply literal equations because we're trying to find V sub 2, butterfly technique. V sub 2 is equivalent to P1V1 T2 over T1 P2. Okay, V2 is equivalent to P1, which is 0.98421 ATM times V sub 1, which is 22.5 liters, times T2, which is... Hang on. No. I'm so sorry about this. I got it all wrong. Return back to the equation. I forgot to eliminate the values of T because again, T1 and T2 have unstated data. So we'll disregard that and we'll have P1V1 is equal to P2V2. I'm so sorry about that. Boyle's law, as you can see, they're both connected to each other. Alright, let's restart. Let's start from this. P sub 1 is 0.98421 atmosphere times V sub 1, which is 22.5 liters, is equivalent to 0.95395 atmosphere, which is this one, times our V2, which is unknown. Divide both sides with this value, and right, give me a few seconds to calculate. Zero 0.98421 times 22.5 divided by 0.95395 atmosphere. We will get 23.21371,665, such that if we round that off to 5 significant units as usual, we get 23.21372 and place an atmosphere unit. This is our final answer. Alright, let's move to another problem. What pressure is required to compress 196 liters of air at 1 atmosphere into a cylinder whose volume is 26 liters? Alright, let's start with enumerating the values as usual. You might ask why I'm still enumerating 3 values and one of them would usually be exempted. It's to prevent confusion. We'll eliminate it once we acknowledge that that is the variable that's not specified. Especially that it's this is not really a practice problem. We're just trying to specify examples so that you may be prepared for further examples relative to this. So for condition 1, we have 196 liters of air at 1 atmosphere. Okay, what's being asked is the next pressure. What pressure is required? So there. And whose volume is 26 liters. This is the one. As you can see, there's no specified data for either temperature, both for temperature 1 and 2. So we'll just declare it as unstated data. There we go. For P sub 2, that's what we're trying to find. There's nothing else that we have to convert here. So far, we only have atmosphere and liter, so which are all default units. Let's move on to the equation making part. So as usual, base it on the combined gas law formula. Pressure, which is 1 atmosphere, Actually, no. Let's eliminate it first. Use literal equations. What we're trying to find is p sub 2. So divide both sides by v sub 2. So this is our formula. Let's move on to the solution part. Alright, P sub 2 is equivalent to 1 atmosphere times V sub 1, which is 196 liters, divided by V2, which is 26 liters. With that, place that in the calculator and we get 7.538461538. Alright, with that, round it off to 5 significant units. 7.53846 atmosphere. That is our final answer. Alright, so please, I'll give you a few seconds to understand, absorb what's just taught right now. I'll give you 5 seconds, or you can feel free to pause the video if it's too fast. Alright, let's move to number 7. A balloon has a volume of 1.2 liters inside a room where the temperature is 25 degrees Celsius. What is the volume of this balloon when it is taken outdoors on a very cold day where the temperature is negative 15 degrees Celsius? Right? Let's enumerate the values. You're gonna get used to it if you keep on practicing. Alright, condition 1, volume of 1.2 liters inside a room where the temperature is 25 degrees Celsius. Alright, we have temperature quantity. And what's the volume of the balloon? So this is what we're trying to find. V2, when it is taken outdoors on a very cold day where the temperature is negative 15 degrees Celsius. This time, pressure has no data. Both pressure 1 and pressure 2. Oops, move it a little, as well as this. There you go. Convert data. We have to convert two temperatures. Convert them to Kelvin. So temperature 1, 25 degrees Celsius to Kelvin. T1 is equivalent to 25 plus 273, which is 298. For T2, we have negative 15 degrees Celsius. Convert it to Kelvin. Negative 15 degrees C plus 273. In other words, T2 is equivalent to 258 Kelvin. Okay, let's move to making the equation. I suppose everything is already stable. All of the variables are in their corresponding default units. So equation, again, we have to base it onto the combined gas law formula. So yeah, this time what's missing is V sub 2, and the unstated data is pressure. Therefore, we have V sub 1 over T sub 1 is equivalent to V sub 2 over T sub 2. Basically, I don't think this is part of chapter 4. This is not Boyle's law because temperature is not constant. Temperature has a given value. So I suppose this question is a bonus. This is not part of our main lesson in this video. I suppose this is all about the... Wait, hang on. Where pressure is constant. I suppose this question is all about Charles's law, because pressure has no stated data. Let's declare this Charles law. This is a bonus. Alright, let's proceed. Transfer T2 to the other side to make V2 alone. Right. For V1, we have 1.2 liters multiplied to V2, which is 258 Kelvin, divided by T1, which is 218 Kelvin. I'm sorry, 298 Kelvin. Right. Let's move up. V2. Place all those values in the scientific calculator, and your answer will be 1.038926174. 0.38926174, correct. V sub 2, round it off to 5 significant units. Again, 1.03893 liters. That is our final answer. So yes, I think that's it. We finished everything. There are no more examples that will be in the future videos. I suppose these are sufficient enough. Yeah, that's everything for this video. We've finally ended the series. Thank you for watching, and yeah, bye.